Welcome to my lecture about ordinary differential equation. In this lecture I would like to show you how to solve homogeneous first order differential equation. So, what it is? If you've got a function m from x, y multiplied by dy over dx, and it's equal some other function n from x and y, then if m from x and y and n from x and y have the same degree, this equation can be considered as a homogeneous. So what does it mean that function f from x and y have some kind of degree? What does it mean? The definition is very simple. If you've got function f from x and y, we can calculate this function from tx and ty, where t is arbitrary constant, and that should equal t in power n multiplied by function f from x and y. And the n is the degree of this function f from x and y, if we can find this n. So let's consider some examples. For example, if f from xy is equal x times y plus x square, so let's calculate f from tx and ty. So, and that will equal tx times ty plus tx squared, and it is equal t square multiplied by x times y plus x square. And definitely that this function have degree 2. Next function. For example, f from xy is equal sine from x divided by y. Then f from tx ty is equal sine from tx divided by ty. And we can write it as a t in power 0 multiplied by sine from x divided by y. And in this case we can say that the degree of this function is 0. Then next example, f from xy is equal cosine x plus sine x. Then if we will calculate the function f from tx and ty, we will have cosine from tx plus sine from ty. So, and then we cannot take t out of this expression. So this function is not homogeneous. So this is the first definition. Another definition which is very similar. If we write this function as a m from xy multiplied by dy over dx, and it's equal n from xy, then we can rewrite it by introducing function f from xy, which is equal n from xy divided by function m from xy. And definitely the degree of this function f should equal 0. So let's prove it. So f from tx ty is equal n from tx ty divided by m from tx ty. And by definition of our degree of the function is equal t in power n multiplied by n from xy and divided by t in power n from times m from xy. And we can cancel t in power n and write that it's equal t in power 0 multiplied by function f from xy. So this function f should have degree equal 0. And the theory says that this function f can be represented as a function q from y divided by x as a parameter. And in this case we can rewrite our differential equation as dy over dx is equal q from y over x. This is another definition of a homogeneous equation. So how to solve this equation? So let's do substitution. V equal y divided by x. Therefore, y is equal v times x, and dy over dx is equal d from vx divided by dx. So this is a product rule, and it will be dv over dx multiplied by x plus v dx over dx. And we can cancel dx over dx, and it's equal 1. We can write that v plus x dv over dx is equal q from v. This is our new equation with substitution of v. So let's rewrite it. So it will be x dv over dx is equal q from v minus v. And one more modification, and we can write dv divided by q from v minus v is equal dx divided by x. And now we can put integration sign and say that we've solved this homogeneous differential equation. But I would like to tell you that it's not very good to use this formula, and it's better to do the substitution and do all the calculation from the scratch for every equation you want to solve. In next lecture I will show you this on some particular examples. If you like this lecture, please subscribe to our channel and wait for new interesting lectures about math and Python. Thank you.